In this video, we're going to learn how to solve an exponential equation with a natural base. And a key to solving these exponential equations with natural bases is understanding how to go from an exponential form to a logarithmic form. So when you see this statement here, x is equal to e to the y, this is equal to y is equal to, because that's the exponent, and since that base is e, it will be the natural log of the other side of the equation, x. Because again, y is the exponent, you raise e to get x. So as long as you understand how to switch between these two forms, you should be able to solve any form of equation dealing with e, the natural base. So let's start with this first example. We want to get this e by itself so we can transfer it to a logarithmic form to get the power alone. So to do this, I'm going to subtract 2, giving me 14 on the right. Then I'll divide by 4. Oop, I'll put an x instead of an e there. Small mistake. All fixed. So this e to the 2x. We'll divide by 4 and get e to the 2x is equal to 7 halves. Also known as 3.5. And then I'm going to rewrite this as the exponent, 2x, is equal to the natural log of 3.5. Again, the exponent is equal to the log base, the exponential base, which is e, so I'll put ln for my natural log of 3.5. And then I can just divide by 2, giving me my solution as x is equal to the natural log of 3.5 over 2. Now, this approximate answer, just so you understand its value. So natural log of 3.5 divided by 2 would be approximately 0.6264. And if you plug this back in, you should get the correct solution. We're dealing with exponentials, so there shouldn't be a domain issue in terms of plugging in, but it can always be safe just to plug in to know that you are correct. So next we have e to the x minus 2. Now in a previous lesson, we did learn how to solve these with just a logarithm, which is still a possible way to solve these. You could just take the log of each side and get log of e to the x minus 2 is equal to log of 12. And then move the exponent out in front. So we get x minus 2 log e is equal to log 12. And then divide by log e. So we get x minus 2 is equal to log 12 over log e. And this, after adding 2, will give you your solution. So log 12 over log e plus 2. Now, this can be written a lot more simply. If you think of your change of base formula, that's also known as log base e of 12, which is just natural log of 12. So to show the other solution of solving this, if you were to just switch its form into the logarithmic form, you would get x minus 2 is equal to natural log of 12 when you switch its form, and then you add 2 and you just get x is equal to natural log of 12 and then plus 2. So a little bit quicker way to get the answer. They both give you the correct solution, but when you can just switch its form so easily, and this being a button on your calculator, it seems like the proper way to solve exponential equations with natural bases is just to switch it to the natural log state if you can. And just to show you that both of these solutions give you the same thing, if I did natural log of 12 plus 2, I get approximately 4.4849. And if I did it the other way, log of 12 divided by log of e. I'm going to put it to the first power, so it's just e. And then plus 2, you would get the same exact number either way. So solve it the way you would prefer, but I suggest always switching to the natural log form if you can, because typically it's a quicker solve. Next up, we have 7 minus 2e to the x over 2 equals 1. So we're first going to subtract 7 to start. So we'll subtract 7 and get negative 2e to the x over 2 equals negative 6 when you subtract 7. Then we'll divide each side by negative 2, giving me e to the x over 2 equals 3. Then we'll switch it to our natural logarithmic form. We'll get x over 2 equals the natural log of 3. And then we'll multiply each side of the equation by 2 to get x by itself. Now when you do this, be careful not to multiply the 3. It's within the natural log, so they can't multiply together. So we'll move that 2 to the front of the logarithm to avoid confusion. So 2 natural log of 3 would be the solution for that problem, for that equation. And just to check about how much that would be, 2 natural log of 3 is approximately 2.1972. And for our last problem, we happen to have 2e to the x's. So we're going to do a very cool move here. We're going to move, actually, since their powers aren't the same, we can't necessarily combine them, but move them all to the same side regardless. So I'm going to subtract e to the x to give me 2e to the x minus 2 minus e to the x plus, equals 7, because now it's alone on the right side. Now e to the x minus 2 can also be thought of as, since they're subtracting exponents, 2e to the x over e squared. Like move that minus 2 to its denominator, like you would if they were subtracting exponents. And then I have an e to the x I can actually factor out. So I have e to the x times 2 over e squared minus 1. Which, to make my life easier, I'm actually going to write that as 2e to the negative 2, just so I don't have to deal with a fraction right here. And to get e to the x by itself, I will divide each side by 2e to the negative 2 minus 1. So that little trick here was just to factor out e to the x, so that e squared is just a number. And now I can just divide that to the right side of the equation, giving me e to the x is equal to 7 over 2e to the negative 2 minus 1. If I kept it as a fraction, I would have had a fraction within a fraction, which I didn't want to deal with. Now to finish solving, I'll switch it to its natural logarithmic form. So the exponent x will be by itself. It'll be equal to natural log of 7 over 2e to the negative 2 minus 1. Now that is the exact answer, but I certainly have no clue what that's approximately equal to, so I'm just going to plug it in and find out. So we'll have the natural log of 7 divided by 2 e, where are you at? E to the negative 2 minus 1. I think I had enough parentheses, and that is a syntax error. So what happens is this expression on the inside is actually a negative number. Oop. Too many parentheses there. I deleted the wrong thing. -1. There we go. Oh, I actually made a syntax error earlier. Let me fix all that. So here, I have to put the -1 there. Then I'll close my parentheses. But it still is a non-real answer, which means that the inside number is negative, which tells me that there is no solution to this equation that would work. So instead of saying that this is a solution, I'll unbox my answer. And say that x does not equal that solution, because you can't have a negative within a natural log. That just can't happen, so we didn't actually find a solution for this problem. So we say there is no solution. And that is how you solve an exponential equation with a natural base.